Hey guys, welcome back from spring break. I know it's kind of weird, but it won't be too different for class because you've done this before whenever I've been gone and things like that. I do miss you guys. Hopefully, we'll be back within a couple weeks and we can get back to normal. If you do need help working on problems, I'm available. Either you can either email me if you want. I think it'd be easier though if you did like a video chat. I'm going to be on Google Hangouts, so you just find that through your web browser, or I can send you an invite if you don't know how to do that. Um, and then that way I can work things out on paper and you can see it. Um, you know, and it's much easier to explain math problems that way. So, please reach out if you need help because this is the way it's going to be for a little bit. So we're going to be starting chapter 9, which is all about radicals, which is square roots, cube roots, fourth roots, any kind of root. So a radical is the opposite of an exponent. So, with an exponent, you multiply something by itself. A root is asking you what number times itself is this number, is whatever is under the radical. So that symbol is called a radical or a radical sign. The expression underneath it is the radicand. So the sign is the radical, the number inside is the radicand. Just gets you some technical jargon there. Okay, so if some number is positive, then the square root of this is asking for the positive square root of a, and this is setting the negative square root of a. So a square root has to be positive. If there's a negative on the outside, that's fine. Your answer is just going to be negative. Okay. The square root of 0, by the way, is just 0 because 0 times itself is 0. So you've seen square roots before, so this section should be not too difficult. So this is asking you the square root of 36. So it's saying what number times itself is 36. So you think, well, 6 times 6 is 36, so the square root of 36 is 6. Number 2, we've got the negative square root of 16. So you just kind of cover up the negative and ignore it and just look, well, what's the square root of 16? Well, 4 times 4 is 16, so the square root of 16 is 4. The negative just kind of tags along, and that gives you the negative 4. Number 3, fractions. As long as the numerator is a perfect square and the denominator is a perfect square, it's not too hard to deal with. You just kind of separate it. What's the square root of 9? 3. What's the square root of 100? 10, because 3 times 3 is 9, and 10 times 10 is 100. So the square root of 9 100ths is 3 tenths. I already told you what the square root of 0 is. It's up here. 0 times 0 is 0. Just put that there because sometimes 0 gives you some funky answers, like undefined or something. But the square root of 0 is still 0. And 0.64. So again, you know what 64 is. 8 times 8 is 64. So 0.64 is going to be 0.8. Okay, now this leads us to this. Is the square root of a negative number a real number? So not this one. Is the negative square root of numbers a negative number? So for an example, would the square root of negative 4 be a real number? And the answer is no. But do you know why? Why can you not have a negative inside of the radical? Well, think about what a square root means. It means what number times itself is the radicand. So what number times itself is negative 4? Well, you think, well, maybe it's negative 2. Well, that's not the case because negative 2 times itself, negative 2, is positive 4. It's not negative 4. So you can't have the square root of a negative number. You can have a negative outside of the square root symbol. You cannot have a negative inside of the square root symbol. That's undefined. It's not a real number. So that's just what you have to remember. It's not a real number because no number times itself is negative. No number times itself is negative. Okay. Now, that's square roots. We can also do cube roots. or fourth roots, or any root. So we'll look at cube roots next. So since 2 to the third is 2 times 2 times 2, which is 8, we call 2 the cube root of 8. So here it is in symbols. So we take the square root symbol and we put, if we're looking for the cube root, we put a 3 for an index. If we're looking for the fourth root or the fifth root, whatever it is, we put the index. So the square root really hasn't understood 2 for an index. We don't put that though. So notice, the cube root of 27 is 3 because 3 times 3 is 27. And also, the cube root of negative 64 is negative 4. Why is that the case? Well, think about it. What's negative 4 times negative 4 times negative 4? 3 negatives is a negative, and 4 times 4 times 4 is 64. So, unlike square roots, you can have cube roots of negative numbers. They are real numbers. So, here's just something so you know. If the index is even, there can't be negative inside, because no even amount of factors will multiply to make a negative. If the index is odd, then that number can be anything. Anything works, because an odd amount of negatives would make a negative, and an odd amount of evens would make it positive. So if it's even, inside of the radical cannot be negative. If it's odd, anything can be inside of the radical symbol. Okay, so we're going to apply that, and we're going to use our brains here a little bit. So cube roots, again, it's asking you what number times itself 3 times is 1. Well, 1 times 1 times 1 is 1, so this one is still 1. What's the cube root of negative 27? So since it's negative, I know my answer is going to be a negative number, and then you just have to think, what number times itself 3 times is 27? Well, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, so it's negative 3. So it might be beneficial to know some of the cubes. Like if you know the cubes up to 5 or 6, you'll probably get everything. So if you don't know what I'm talking about, 1 cubed. If you know that 1 cubed is 1, if you know that 2 cubed is 8, if you know that 3 cubed is 27, if you know that 4 cubed is 64, and 5 cubed is 125, that's going to get you a long way if you know those. 6 cubed, what is that, 196? I don't even know. 216. See, I don't even know 6 cubed, but if you know that many, you'll probably get most of the problems you'll ever be asked. So we look at number 3. Knowing these cubes is going to help you. What's the cube root of 1 over 125? So remember, fractions don't make it any harder. You just have 2 separate parts. What's the cube root of 1? 1. What's the cube root of 125? It's 5. We checked it out over there. 5 times 5 is 25, times 5 is 125. So the cube root of 1, 125th is 1/5. If you took 1/5 and multiplied it by itself, 1/5 times 1/5 times 1/5, you would get 1 over 125. Okay, down here, we're going to be doing bigger roots, 4th roots and 5th roots and 6th roots. So I'll show you how to do it on a calculator, I think. Now, sadly, I didn't bring any of my one calculators, the ones that I recommended in class home, but I can kind of walk you through it. So on your calculator, on the left-hand side, you've got something similar to this. You've got a square button, and then up above it is the caret key, right? So the caret key above it is going to be a little square root button with the X next to it. So you'll hit second and that one. But before you do that, you got to look at the index. So if your index is 4, like on number 1, you hit the 4 first, and mine's going to look a little different, but I'll show you. So look, this is what you're looking for. That's the symbol above the button you're looking at. So you're going to hit second, the one that's underneath that button. So it should look like this on your calculator too. It's got the little X with the square root. And then what's the radicand? 16. So you do the 4 first, second, then the caret key, and then 16. And it should come out to be 2 because 2 times 2 times 2 is 16. Times 2. I missed one. So then just try it on your calculator. So again, 5 first, second, the caret key, and then this time negative 32. So remember, you got to hit the actual negative button. You got to hit the negative button, not the minus button. So this is the 5th root of negative 32. This one comes out to be negative 2 because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. All right, on number 3, again, just kind of ignore the negative that's out front and look at what's the cube root of negative 8. This one we should know. It's negative 2. Well, there's also a negative out front. So I'm going to put it in parentheses like that. So what does that really come out to be? It comes out to be positive 2 when you simplify it completely. Number 4, this one's trying to trick you. It's the 4th root of negative 81. Remember, on even indices, you cannot have a negative inside. This one is no real solution, or just no solution, it's fine. We can do the 4th root of positive 81. I just know it is 3, but again, 4 first, second, caret key, get that one that looks like that, and then 81, the 4th root of 81. So what that is saying is that whatever number is out front is taking the place of the little index x. So it's 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. This one should be apparent. What's the 5th root of 100,000? Well, there are 1, 2, 3, 4, 5 zeros, so that's going to be 10. Number 7, 6th root of negative 64. Once again, even index, negative inside, no real solution. And then the cube root of negative 125 is negative 5. Again, I know a lot of those cubes. And then if you don't, you just type them in. Okay, so we move on. Next. So remember that these numbers, 1, 4, 9, 16, 25, and 4 25ths, are all perfect squares because they're some number squared. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. So when you take the root of a number that doesn't go evenly, you get what's called an irrational number because it goes on forever in a non-repeating fashion. So you can find a decimal approximation of those types of numbers. So if it's not a perfect square and you take the square root of it, it comes out to be an irrational number, like the square root of 3 and the square root of 17. Those are not perfect squares inside of the radical, so it's a decimal approximation. So again, yours looks very similar. Your square root button is above your squared button. So you hit second square root button, and then we're typing in 3. It's going to then be in the habit of closing that parenthesis. So it asks us to round this to the nearest 3 decimal places. So that 0 would not round that 2 up, so it's going to be 1.732. We're just checking to see, can you type things into your calculator correctly here. So make sure your calculator, you can get this to match. So we're going to do square root of 17 this time. Make sure you close that parenthesis. Round it to 3 decimal places. So my 4th number is a 1. It does not round the 3 up, so it's going to be 4.123 rounded to 2 decimal places. Now, we're going to take it one step up. This is not too difficult, though. We can also find radicals that contain variables. So what that does is, whatever the index is just going to really divide the exponent on a variable. So remember, square roots have an understood index of 2. So we're just going to divide. 2 divided by 2 is 1. So z to the first, but you wouldn't really put the first. You just say z. Again, this has an index of 2. It's going to cut those exponents in half. It's going to be x to the third. This one is the cube root of 27y to the 6th. So you want to do this piece by piece. First, do the cube root of 27. What's the cube root of 27? We know that one. It's 3. And then take the exponent. So for the variables, you divide the exponent by the index. So 6 divided by 3 is 2. So it's going to be 3y squared. Again, index of 2 for this one. What's the square root of 16? That's 4. And then take the exponent and divide it by the index. So 4x, 16 divided by 2 is 8. 4x to the 8th. With fractions like on number 5, doesn't make it any more difficult. You just do it piece by piece. Again, this is a square root, so it's an understood index of 2. For variables, we take its exponents and divide it by the index, so that's going to be x to the second. On bottom, the square root of 25, we all know, is 5. On number 6, again, do it piece by piece. This time I have the cube root of negative 125, so I'm ignoring the variables behind it. What's the cube root of negative 125? That's going to be negative 5. And then for variables, you take the exponent and divide it by the index. 12 divided by 3 gives you a to the 4th. 15 divided by 3 gives you b to the 5th. So why don't you try 7 and 8? Pause the video, try them, see if you get them right. Otherwise, here we go. So this is going to be negative 2, 6 divided by 3 is 2, 12 divided by 3 is 4. So negative 2, a squared, b to the 4th. And on number 8, the 4th root of 81 is 3. 4 divided by 4 is x to the 1st, but I wouldn't put to the 1st. 8 divided by 4 is y to the 2nd. 32 divided by 4 is z to the 8th. So 3xy squared, z to the 8th. Bang. All right. Bottom of this page, we're just going to, they're going to say either use the f function or the g function and just plug it in and simplify and do as much as you can. So it says this time use the f function, plug in 8 into the f function. So I'm going to write down the f function. It is x minus 4. This time we're plugging in 8. So it's the square root of 8 minus 4. Do the math inside of there. 8 minus 4 is 4. Square root of 4 is 2. So you get 2 with all of that. This time we're going to plug in 6 into the f function. Again, write down the f function. It's the square root of x minus 4. So it's going to be the square root of 6 minus 2. Oh, 6 minus 4, sorry. Which is the square root of 2. So that's the radical answer. That's not a perfect square, so I can't remember if they ask you for a 2 decimal, 3 decimal approximation. So you type that into your calculator, square root of 2. We'll round it to the 3 decimal places like we did before. 1.414. Approximately, right? 3 and 4 are using the g function, which is the cube root of x minus 3. So I like to write down the function I'm using because I'll make fewer mistakes that way. So I've got the cube root of 11 minus 3, which is the cube root of 8, and the cube root of 8 is 2. This time we're plugging in negative 5 into the g function. The g function, again, is the cube root of x minus 3. So that's the cube root of negative 5 minus 3, which is the cube root of negative 8. Cube root of negative 8, negative 2. So you'll see some of those problems on your assignment. No big deal. Last thing is quick graphs. We just want to look at what do these graphs look like, by the way. Just a normal square root of some number or the cube root of some number. What does that function look like? So to do that, we're just going to pick a few values. We're going to make a few values of x and y that are convenient for us. So I'm thinking about, I'm going to be taking the square root of numbers. So I'm going to pick 9. I'm going to pick 4. I'm going to pick 1. I'm going to pick 0. I can't pick negatives, right, because you can't have negatives. I also, that's probably good enough, actually. So I plug it in. What's the square root of 9? 3. What's the square root of 4? 2. What's the square root of 1? 1. What's the square root of 0? 0. So this is going to be a rough graph of those points. So at 9, we are at 3. At 4, 1, 2, 3, 4, we are at 2. At 1, we are at 1. And at 0, we are at 0. I can't pick negatives, so this is actually kind of a ray. It starts here and stops here. It doesn't go any further. It goes like this. that's what a square root function looks like. So is it linear? No. Notice it's going to be really curvy right here at the end. So it's nonlinear. It's not a straight line. It's not even a line because it stops right there. And you can only have, it's got the domain can only be values of x that produce positive numbers in there. The range is anything above 0. So all of those things. So this is what a typical square root function looks like. And we can do shifts to that, and you'll see that later, to move it up or down or left or right. But that's what it will always be, the shape of it. We can stretch it out or smush it. So let's look at what a cube root function will look like. So remember, with cube roots or any odd index, you can choose whatever numbers you want for x and y. So we can have negatives and positives. Now, we can't pick, and then we just want to be strategic about the numbers we're picking. Right, we want to pick 8 because it's a perfect cube, which means we also want to pick -8 because it's a perfect cube. And that is 2 cubed, right? So the cube root of 8 is 2, the cube root of -8 is -2. So I can't really pick anything bigger than 8 because my graph only goes to 10 in all directions. So then the other numbers we'd pick is 1, -1, and 0 as well. So what's the cube root of 1? Well, it's 1. What's the cube root of -1? It's -1. What's the cube root of 0? It's 0. So we plot those points. 8, 2, -8, -2, 1, 1, -1, -1, and then 0, 0. So what's that look like? So if you were to do some more points, it's kind of curvy in there, so don't make it all jaggedy. It goes like this. It hits here, and then it goes curvy, curvy, and then it goes like that. So that's what a cube root function looks like. It's pretty interesting. Again, it's non-linear, but it does go forever in all directions. So the domain of a cubic function is all real numbers. You can always pick anything. The domain of this one, you have to pick values that produce positive numbers. The range, again, is going to be all real numbers for these ones as well. That range up there is defined. All right, so again, if you have questions, please do reach out. Google Hangouts is probably going to be your best bet. Send me an email if you don't know how to do that, or just send me whatever you need to. Good luck. Ask questions, please. Again, I miss you guys. Hopefully, we'll see each other soon. And also, if you want to do a Google Hangout just to say hi, that'd be great too. See you later.